Hello viewers, welcome to the channel DPC Smart channel এ আপনাদের সবাইকে স্বাগত জানাই। Here we have a special announcement for you. We have started our online physics classes for the class of 11 for the year 2026 onwards. So in addition to the MAKAUT B.Tech physics syllabus lectures, we have also started online physics class for class 11 from 2026 onwards. So if you want to join our online physics class for the class 11, you can easily contact us through the contact numbers given in the background of my screen by directly messaging there, and also on social networking sites there also you can directly message there. If you want to join our online classes for MAKAUT B.Tech physics syllabus paper code page 101 and 201, you can also join there by contacting the numbers given in the background of my screen. For B.Tech students, we also solve numerical problems, previous year numerical questions as well as previous year questions, and discuss everything related to MAKAUT B.Tech physics syllabus and examinations. Class 11 এর physics online ক্লাসও শুরু হয়ে যাচ্ছে 2026 থেকে অনওয়ার্ডস থেকে। তোমরা যারা ইচ্ছুক তারা এই নাম্বারে ব্যাকগ্রাউন্ড অফ মাই স্ক্রিনে যে নাম্বার দেওয়া আছে ওখানে হোয়াটসঅ্যাপ করে তোমরা এনরোল করতে পারো, অ্যান্ড দ্যাট উড বি টোটালি অনলাইন বেসিস, class 11 physics all boards. And another thing I want to say is that I have seen that many of you are viewing my videos, and thanks for viewing the videos, but you are not subscribing. All the theory lectures you are getting here free of cost, so it will be appreciated if you kindly subscribe. তো সবাই একটু সাবস্ক্রাইব করে দিও, কারণ সাবস্ক্রিপশনটা হচ্ছে না, সাবস্ক্রাইব করছো না তোমরা, ভিউজ পাচ্ছি অনেক, বাট ইউ আর নট সাবস্ক্রাইবিং দ্য চ্যানেল। সো প্লিজ সাবস্ক্রাইব দ্য চ্যানেল DPC Smart. After Wien failed to explain the whole blackbody radiation, then scientists Rayleigh and Jean came with their classical theory. So British physicists Lord Rayleigh and James Jeans, they came with the classical theory and they tried to explain blackbody radiations with their own approach. And to explain blackbody radiation, they considered some assumptions for the blackbody. First assumption was the radiation in a blackbody cavity that would be electromagnetic in nature. Secondly, those cavity will be filled with diffuse radiation that will consist of all frequencies starting from 0 to infinity. Thirdly, energy exchange between the radiation and the matter would be in discrete manner. Fourth assumptions they made, that is, a large number of electrical charges or electrons will be present at the boundary or the wall of the blackbody cavity chamber. And those charged particles will act as harmonic oscillators and they will produce electromagnetic waves. And those waves will be reflected back and forth from the wall of the cavity, and those waves will be reflected and they will produce standing waves, and those standing waves will have some modes or independent frequencies. And when the system is in thermal equilibrium, that number of modes or number of independent frequencies of the standing waves, that will be equal to the number of oscillators present within the blackbody chamber or cavity. And that number of independent frequencies or modes per unit volume within unit frequency range nu to nu plus d nu of the standing waves becomes equals to number of oscillator within the same range, and that is denoted by capital N function of frequency nu. So they made these assumptions to explain blackbody radiation. Again repeating the assumptions made by Rayleigh Jean to explain blackbody radiation. For my Bengali speaking listeners, first of all, Rayleigh and Jean তারা কি অ্যাজিউম করলেন যে উইদিন দ্য ব্ল্যাক বডি চেম্বার ইলেকট্রোম্যাগনেটিক রেডিয়েশনস দিয়ে পুরো ফিল্ড আছে, এবং এই রেডিয়েশনসগুলো হবে ইলেকট্রোম্যাগনেটিক রেডিয়েশন, অ্যান্ড দ্যাট ইলেকট্রোম্যাগনেটিক রেডিয়েশন উড বি ডিফিউজ রেডিয়েশন উইদিন দ্য ব্ল্যাক বডি চেম্বার, এবং ব্ল্যাক বডি চেম্বার টোটালি ফিল্ড উইথ ডিফিউজড ইলেকট্রোম্যাগনেটিক রেডিয়েশন। অ্যান্ড উইদিন দ্য ব্ল্যাক বডি চেম্বার ইলেকট্রোম্যাগনেটিক রেডিয়েশনের ফ্রিকোয়েন্সিসগুলো হবে all possible frequencies, means 0 to infinity যে কোনো ধরনের frequency that is possible within the blackbody chamber. And third assumption, that was very much important assumption, that is the main classical nature approach or classical approach for Rayleigh-Jeans law, that is energy exchange between radiation and matter that would be of any amount, মানে যে কোনো অ্যামাউন্টের এনার্জি এক্সচেঞ্জ হবে রেডিয়েশনের সাথে ম্যাটার মিন্স ওয়াল অফ দ্য ব্ল্যাক বডিজ, মানে ব্ল্যাক বডির সাথে রেডিয়েশন বা ব্ল্যাক বডি ওয়ালের সাথে যে রেডিয়েশন অফ দ্য ব্ল্যাক বডি, তার ইন্টারাকশনটা যে কোনো অ্যামাউন্টের এনার্জির হতে পারে, দ্যার ইজ নো রেস্ট্রিকশন। Next assumption was large number of electrical charge particles, especially electrons present থাকবে ওই ব্ল্যাক বডি ওয়ালের ইনার পার্টে, যে ইলেকট্রনগুলো হারমোনিক অসিলেটর হিসেবে কাজ করবে, এবং দ্যাট হারমোনিক অসিলেটর উইল প্রডিউস স্ট্যান্ডিং ওয়েভস। হাউ? Those harmonic oscillators will produce electromagnetic waves. Those electromagnetic waves, they will be reflected back and forth from the wall of the chamber. After reflection, superpose korbe, they will superpose and they will produce standing waves. And standing waves will have certain independent frequencies, or which are called modes. স্ট্যান্ডিং ওয়েভসগুলো কী করবে? মোডস ক্রিয়েট করবে। মোডস মানে হচ্ছে স্ট্যান্ডিং ওয়েভসের ইন্ডিপেন্ডেন্ট ফ্রিকোয়েন্সি, যতগুলো ইন্ডিপেন্ডেন্ট ফ্রিকোয়েন্সি থাকবে ততগুলো মোডস ক্রিয়েটেড হবে। এবং অ্যাট থার্মাল ইকুইলিব্রিয়াম ইলেকট্রোম্যাগনেটিক রেডিয়েশন ডেন্সিটি or electromagnetic energy density would be energy density of the charged particle present within the black body. But that number of independent frequency or number of oscillators present within the cavity, that they Rayleigh Jean determined and they calculated. Number of such independent frequencies or modes per unit volume within the frequency range nu to nu plus d nu, that would be equals to number of particles or oscillators present per unit volume within the frequency range nu to nu plus d nu, and that value was denoted by capital N, which is a function of frequency, and they calculate that the value of that capital N, number of oscillator present as per unit volume within frequency range nu to nu plus d nu, and they calculated the value of number capital N function of nu, that they found the number of charge particle per unit volume within the frequency range nu to nu plus d nu, they found this value 8 pi nu square by c cube into d nu. So that number is proportional to nu square, frequency square. So এটা হচ্ছে কতগুলো নাম্বার অফ চার্জ পার্টিকেলস আছে বা অসিলেটার্স প্রেজেন্ট আছে উইদিন দ্য ব্ল্যাক বডি প্রতি ইউনিট ভলিউমে। এটা হচ্ছে এই ভ্যালুটা, এটা ওনারা ক্যালকুলেট করেছিলেন। So if we want to calculate total energy of the radiation leaving the cavity per unit volume, so what we have to do? We have to multiply this number with average energy per oscillators, which is denoted as this one, denoted by this one. So আমরা টোটাল কতগুলো নাম্বার অফ অসিলেটর প্রতি ইউনিট ভলিউমে আছে উইদিন ফ্রিকোয়েন্সি রেঞ্জ নিউ টু নিউ প্লাস ডি নিউ, যদি এন পেয়ে গেছি ক্যাপিটাল এন, এটাকে যদি উই মাল্টিপ্লাই দিস উইথ অ্যাভারেজ এনার্জি পার অসিলেটর, then if we multiply both we will get the total energy within the whole black body. কতগুলো অসিলেটর আছে আমরা জানি, প্রত্যেকটা অসিলেটর অ্যাভারেজ এনার্জি আমরা ক্যালকুলেট করব, তাহলে দুটো মাল্টিপ্লাই করলেই আমরা পেয়ে যাব টোটাল কতটা এনার্জি আছে উইদিন দ্য black body chamber cavity. So the total energy of radiation leaving cavity would be capital N into average E, that is average energy of each oscillator. Now we have to calculate average value of energy of each oscillator. So average is denoted as E, average value would be denoted as integration 0 to infinity e to the power minus beta E dE divided by 0 to infinity e to the power minus beta E dE, where this term is called Boltzmann factor. So যে কোনো একটা অবজারভেবলের যে কোনো একটা কোয়ান্টিটির অ্যাভারেজ টাইম অ্যাভারেজ or average value we can calculate using this process or using this formula. At 0 to infinity we want to calculate the time average of E, that is average energy per oscillator. So that would be that can be written as 0 to infinity integration E to the power Boltzmann factor e to the power minus beta E into D. This is called Boltzmann factor, this one, Boltzmann function or factor. So capital E into d to the power minus beta E by beta into E into D divided by just integration 0 to infinity e to the power minus beta E d. So we have to calculate this average value. Now this would be equals to, we can write this as minus del beta of logarithm in bracket 0 to infinity e to the power minus beta E dE. So what we can write? We can write this expression as this one. If you notice very closely, you can see that this total expression we can write in this form. So minus del del beta of logarithm 0 to infinity e to the power minus beta E dE. Because if you differentiate this term, total term, you will get this upper term in the back process. So now next we can write that minus del del beta of logarithm of integration 0 to infinity, this integration value will be 1 by minus beta e to the power minus beta E into 0, limit would be 0 to infinity. This would be integration value. Now in next line what we can write, minus del del beta logarithm of this minus will be cancelled with this minus and it will be plus this and this will be plus. So del del beta of logarithm value would be e to the power minus infinity minus 1 into there will be logarithm of 1 by beta will be remaining. So it will be minus del del beta of logarithm of 1 by beta and minus 1. So this minus will go outside. So minus del del beta of logarithm of 1 by beta, where beta is given as K into Boltzmann constant into absolute temperature T. So beta is known as Kt. So this average value of each oscillator, energy of the each oscillator average value would has been found as just Kt. This can be also explained with the equipartition of energy. In many books you can find that they have used equipartition of energy, but here I have derived in a different manner. Using equipartition of energy, you can also just write down E expectation would be Kt, but here we have derived in a different manner. That is the total energy radiation leaving the cavity per unit volume. That would be that total energy within the, that is leaving cavity, the black body cavity per unit volume per unit frequency U nu T. So N nu into Kt. The N value was found 8 pi nu square by C cube d nu into Kt. The total here you have to write total energy leaving the cavity per unit volume, not per unit frequency. If you want per unit frequency, then you have to omit this d nu. So this is the total energy then leaving the cavity per unit volume or energy density. That energy density is given by u nu T equals to 8 pi nu square by C cube d nu into Kt, or u nu T d nu, that would be equals to 8 pi nu square by C cube Kt into d nu. This is called the Rayleigh-Jean law or Rayleigh-Jean formula for black body. Now if you want to calculate the energy density per unit volume per unit frequency, then you have to write just u nu T equals to 8 pi nu square by C cube into Kt. So the Rayleigh-Jean formula, Rayleigh-Jean law, it was found u nu T d nu, that is equals to 8 pi nu square by C cube Kt d nu. So this is one form, that is in the form that is the function of frequency and absolute temperature. Now if you want to write Rayleigh-Jean formula in terms of wavelength, then you have to convert this frequency into wavelength. That means you have to write in terms of not in terms of frequency, you have to convert this energy density in terms of lambda T. So you have to find u lambda T. And what you have you have to do, so you have to convert this from here to here. So what change you have to do in the right hand side? So you have to change. We know nu equals to c by lambda. So d nu mod, that would be c by lambda square d lambda. So new energy density would be, that would be energy density function of lambda t. Here it would be d lambda. Right hand side would be 8 pi nu square. Nu square means c square by lambda square. Again here it is c cube into kt into d nu means c by lambda square d lambda. So this cube, c square and c cancels out. Then it will be 8 pi kt d lambda by lambda to the power 4. So this would be the new form of energy density in terms of wavelength and temperature. This is also Rayleigh-Jean law in terms of wavelength and temperature. And according to the question, you have to state or you have to write whether it is a function of whether it has been asked to write in function of frequency or temperature or wavelength or temperatures. According to that, you have to answer. If nothing has been asked, nothing has been stated, then you can easily write with this frequency form, in this form. Limitation of Rayleigh-Jean's law, which is also known as ultraviolet catastrophe. Now we have to know the limitations of Rayleigh-Jean's law. For that, we have to check or we have to notice the energy distribution graph for blackbody according to Rayleigh-Jean's law. Now this is the energy distribution or radiation energy density distribution graph for Rayleigh-Jean law. This one is for Rayleigh-Jean's law and this one for experimentally observed data. Now you can see that at this along x-axis frequency has been plotted, along y-axis that is nu t, u nu t, that is radiation energy density has been plotted. So you can see, or we can see rather from this graph, that Rayleigh-Jean's graph or Rayleigh-Jean's law fits well in the region of low frequency region, but it fails in the high frequency region. So you can see that for the low frequency region this law is valid. At very high frequency, that Rayleigh-Jean's law, according to Rayleigh-Jean's law, u nu, that means radiation energy density, goes to infinite value. And similarly, if you plot u in terms of lambda, so u lambda t versus lambda, if you plot this graph is for Rayleigh-Jean's law. So at high frequency this law invalids, that means low wavelength region this law invalid, but at high wavelength value this is valid. That means low frequency or high wavelength value it is valid, and low wavelength and high frequency value Rayleigh-Jean's law is invalid. So this is the limitation of Rayleigh-Jean's law, and that is also known as ultraviolet catastrophe. This came as a question in semester 2024. So the question was, what do you mean by ultraviolet catastrophe? So to answer this, you have to first draw the diagram energy density distribution graph, that means u function of nu t versus nu graph. So you have to start from this graph, and first of all you have to write the Rayleigh and Jean formula, that is u function of frequency and time, that is 8 pi nu square divided by c cube into kt into d nu. So first of all you have to write down this Rayleigh-Jean formula, then you have to draw this graph, not Wien's law graph, just only Rayleigh-Jean's and experimentally observed graph that you have to plot. Then what you have to say, that according to the Rayleigh and Jean law, that energy density per unit volume per frequency, that is proportional to nu square, that means frequency of the radiation square. Now as frequency goes to infinity, u nu, that means u energy density u nu t, that also goes to infinity. So energy density goes infinite energy density, that has no meaning, but according to Rayleigh-Jean's law, radiation energy density is going to infinite value, that means very high infinite energy density value within the blackbody chamber. But in practical case it was found, so this was experimental or practical case, experimentally observed data, it was found that with high frequency that energy density goes to 0. So there is a discrepancy or shortcomings of Rayleigh-Jean's law as the Rayleigh-Jeans law becomes invalid at ultraviolet region, that means very high frequency or UV region. That's why it is called ultraviolet catastrophe. That means very high frequency or in the ultraviolet region, Rayleigh-Jeans law deviates from the experimentally observed data, and that phenomena is called ultraviolet catastrophe. So in short, in brief, what is ultraviolet catastrophe? So first of all, you have to write down the Rayleigh-Jeans formula, and from there we can see that energy density is proportional to frequency of the radiation square, that means mu square. Now at very high frequency, when frequency goes to infinite value or very high value, infinite value means suppose in the ultraviolet UV region or ultraviolet region, that frequency value is very high. So in that region, energy density should also be very high. That means whenever frequency goes to infinite value, energy density also goes very high infinite value. But in practical case, it was found that for blackbody radiation, energy density is 0. That means becomes minimum 0. So at high frequency or in the ultraviolet region, the Rayleigh-Jeans law does not fit well with the experimentally observed data. That's why it is called ultraviolet catastrophe. Now, where did Rayleigh and Jean go wrong, or who came to solve the ultraviolet catastrophe and how the ultraviolet catastrophe was solved? That will be discussed in the next video. So see you in the next video lecture of quantum mechanics. Till then, bye.